slope. We've mentioned slope before, but we haven't completely really dived into everything there is about slope. So there's kind of four little things I want to talk about as far as slope goes. So first, let's talk about the definition. What is the slope of a line? We can think of it as the steepness. We can think about it how it moves from left to right, how the line moves from left to right. So that's a good way to think about it, okay? So it's the steepness, how it moves from left to right. There's a formula you're going to have memorized, okay? So one thing you guys have to remember is as you were doing these notes, you don't just want to show me a picture of them and walk away. You use those notes and, oh, Mrs. Hott did an example like that. Let me take a look at that example. Oh, Mrs. Hott had a formula in the notes that we wrote down. Use that as, so you should be using this as your guide. There's some formulas you need to know for the slope. You can think about it as rise over run. You can think about it as the change in y. And when you get in upper level mathematics, they're going to use that delta symbol. It just means change in. The change in something. So delta y over delta x is the change in y over the change in x. So the formula, the more formal actual formula, is y2 minus y1. The change in the y, how did my y change, over the change in the x's, x2 minus x1. So the definition is, how is my line moving from left to right? It's about its steepness. If you have a slope, let's say, of 2, you really want to always think about it as a part over another part. So you really want to rewrite that as 2 over 1. And the movement of the line would be up 2 and to the right 1, from one point to the next. It is the movement of the line from point to point. So if we take any 2 points on that particular line and connected them, we could rise some factor of 2 up and 1 over. If your slope happens to be negative, let's say negative 1/3. So a positive 2 line is steep to the right. A negative 1/3 is going downward, but it's not very steep because it's only 1/3. And so this one, you could either go down 1 and to the right, but you can also do the exact opposite. You are allowed to go up and then to the left, because a positive over a negative is the same as a negative over a positive. A zero slope is indicating that we have a horizontal line. An undefined slope, I'll just put UNDEF for undefined, is indicating that we have a vertical line. So a positive line slopes up to the right. A negative line slopes down to the right. A horizontal line has no steepness. It's perfect and lovely and wonderful. Our little math bug can just walk on it real nicely. An undefined slope is a vertical line. We can't walk on it. We would fall off. We're not Spider-Man. Okay? So I just want some graphs to be able to, for you to have a visual. Okay? So just make 4 little under each one of these for a minute. So we're going to look at what does a positive slope mean? What does a negative slope mean? What is a zero slope? and what is an undefined slope. So we should be able to stare at a line without doing any math at all and determine if the slope is positive, negative, 0, or undefined. A positive slope is rising to the right. If my little math bug was walking on the line, he would be going uphill. Your math bug would go uphill as he looks to the right. A negative sloping line goes downhill from left to right. So if my little math bug was staring to the right and walking to the right, he would be going downhill. So it is how we move from left to right. A horizontal line has a 0 slope because there is no steepness. I would rise nothing but go to the right one, or rise nothing and go to the right one, or however many I wanted to go to left or right. And then an undefined slope would be a vertical line like that. Okay. You can't really walk on that line. As a person, we would fall off it. Okay. So you have to be able to recognize what a line is doing and know, hey, that line should be positive. Why didn't I get a positive answer? And so knowing the formula and knowing what to expect is very helpful. Now, you guys are smart. You're in this class, and you should be recognizing these things. You might have to study a fact that you know, I need to know that formula. And as you go through these things, make sure you're looking those things over. So let's practice using the formula. In this first example here, it says to find the slope. We're going to use the formula for A, B, and C, and then we're going to also use the slope-intercept form for D. Okay, so let's use the formula. Let me write down the formula for us. The slope would be y2 minus y1 over x2 minus x1. Now let me give you the strategy that you want to use. If you want to find the slope between 2 points, label the points x1, y1, and x2, y2. Now, it really doesn't matter which one you call x1, y1, and which one you call x2, y2. It doesn't matter. I do tend to just go left to right. If you take calculus in your future, sometimes it matters, but not completely. So let's go ahead and plop those into the formula. Now, the thing to be concerned about, this should be a pair. See how y2 and x2 are above one another. This should be a pair. So that's the way to check your work, okay? You are always subtracting them, so that second sign will always flip. If it was positive, it will become negative. If it's negative, it'll become positive. Okay, so let's plop the stuff into our formula. So y2 is negative 8. I don't know why there's such a big gap there, but it's negative 8, and y1 is 4. Let's plug those in. So that's negative 8 minus 4. Now let's plop in the x's. So our x2 is 6, our x1 is 3. So that's going to be 6 minus 3. See how you can tell? See how this is a pair? So we can see that's a pair. 6 goes with negative 8. 6 goes with negative 8. And this one is a pair. 4 and 3 go together. 4 and 3. That's the way to check. They should be above one another if they are a pair, okay? And now you just do the math. So negative 8 minus 4 is negative 12. 6 minus 3 is 3. Now, normally we would reduce that. 3 goes into negative 12 4 times. We would write it as negative 4. And if you told me the slope is negative 4, that's correct. But because we are thinking about the movement, the rise over the run, it's not a bad idea to keep the 1 there. And that's a time where keeping the 1 there might be a good idea, because then you see both the rise and the run very clearly. But if it's a whole number, you want that run to come from the 1 that would be underneath it. Everybody good with A? Okay. Now let's do it again. Again, the strategy. Label your points underneath. Label your points underneath. Plop it into the formula. Negative 8 minus 4 over 3 minus 3. This should be a pair. It is. This should be a pair. That's a good way to check your work. And then do the math. you get negative 12 over 0. Now, when you get negative 12 over 0, if you try to put that into a calculator, the calculator, I believe, says domain error. It's telling you, that doesn't work. If you get something like this, technically it's undefined. You have technically found a vertical line. Okay? So when you get 0 denominator, you have found a vertical line. That's going to happen anytime our x values match. Because remember, we learned that a function, the x values can't match. Well, a vertical line is not a function, and so the x values always match. Everybody good with those first two? Let's do it again. Label your points. Let's plug into the formula. So our x1, y1 is 3, 4. Our x2, y2 is 6, 4. So if we do the y2 minus y1 over x2 minus x1, we get 4 minus 4 over 6 minus 3, which is 0 over 3, or 0. Now, it's not a bad idea to keep it 0 over 3 because of the fact that then you'll see a rise over run. But a 0 slope tells me that you have found a horizontal line. And that happens when the y values match. So if the x values match, you find a vertical line. If the y values match, you should find a horizontal line because they're at the same height. So 3, 4 is at the same height as 6, 4. So you get that horizontal pattern. Now, for any questions about A, B, or C? Now, D is actually the easiest one of all. It is in that format y equals mx plus b. So we just get to pull out the coefficient that's on your x. Now, if you don't see a coefficient on your x, just put a 1. Yes? Yeah.
Is there a term that goes with it?
Oh, no. So if you get 0, you can just leave it the number 0 and don't have to put anything else. So that's a good thing. So for a vertical line, you have to tell me something. For the vertical one, you can either write the word undefined. You can even use that null set symbol. That's okay, too. A 0, we want it to be something more special than it is. It's just 0. So feel free to leave it 0, and you don't have to do anything. Thank you. Good question. Now, D, since it's in that slope-intercept form, we just get to pull out the coefficient. And the coefficient is that thing stuck on our x. If you don't see it, it's a 1. And so for this, our slope is 2. Now, you can just tell me the slope is 2. You don't have to tell me anything further. Writing it as 2 over 1 would be helpful if you were to graph it. Okay? So that's when it's helpful to see both numbers. But the answer is the slope is 2. Okay. Everybody understand or have any questions about example 1 or need more clarification about A through D there? Okay. So for number 2, we're going to find the slope, and then we're going to graph it each of these. Now, we're technically not only going to find the slope, but we're going to find the y-intercept as well. So let's start with A and B. The slope is our coefficient on our x term. When you don't see it, feel free to put a 1 there. So our slope is negative 1. Now, because it's not fractional, put it over 1. That's going to help us as we graph it. Your y-intercept, remember, is your b. In this case, it's positive 4, or the 0.04. Okay. So get your graph paper ready. And I've stolen the graph paper. When it's time to do homework, I'll give you guys some graph paper. If you need some, feel free to grab some. So we're going to make our xy axis. Okay. So make your xy axis, and we'll graph these together. Now, there are lots of ways to graph a line. Okay, there's lots of ways to graph a line. And so you can do lots of different techniques. But here's the way that I think you want to do most often for these. The first thing you want to do is you want to find your M and your B when it's possible. Second thing you want to do is you want to start at the point 0b. And then you're going to use your slope to move to the next point. Okay, so for the most part, the most efficient way to graph a line is to find the slope in the y-intercept, the m and the b, start at that first 0b point, and then use that slope to move to the next one. That's the best way or easiest way to graph most lines. So our first equation is y equals negative x plus 4. Our slope is negative 1. Our b is 4. So this is how you proceed. You start at positive 4. Put your dot. The slope is going to tell us how we move to the next location. So we're going to go, negative 1 tells us we're going to go down 1 over 1. Down 1 over 1 as many times as we want. You definitely have to do it once. Down 1 to the right 1. But you can do it as many times as you want because the slope is how the steepness never changes in a line. And then you're going to connect it, stretch it across your graph paper. If you want to use a ruler, you can. You know, I'm okay with a nicely sketched graph that you've cared about it. You don't have to use a ruler. Eventually, we'll get to systems of equations where you want to use a ruler because you have to be more precise. But for here, you can or you can't, doesn't matter. Any questions on how we did A? Any questions on that one? Okay, let's do B. Can somebody tell me what is our slope of B? Anybody tell me what the slope of that one is? Jaime, what you think? What's the slope of this line? You got it. And then our starting point is going to be that B. Can somebody tell me what my B is? Negative 1. So that is the point, 0, negative 1. So go down there. That's your starting point. And then we are going to travel up 1 to the right, 2, up 1 to the right, 2, so that we have a positive sloping line. Now, again, I'm not the greatest line maker. Now, my iPad helps me, but, you know, using a ruler, just doing your best. It doesn't have to be super fancy. Everybody good with how we did A and B? That's the quickest way to graph a line, okay? Now, C and D, you just have to recognize what they are, okay? So this one is horizontal. This one is vertical. You just have to know that. I don't know how else to tell you. I mean, it's just a matter of you have to know that fact. So if it's y equals a number, my y is stuck at a height of 1. So go over to your graph paper. Sometimes I'll even hit the where y is 1, where we have a y-intercept of 1, and then I'll put it down. So you can't, you know, the slope is 0 technically. For that one, the slope is 0. And the y-intercept is 1. So if you want to actually pull that out, you can. Now the vertical ones, they don't really have a y-intercept very often. So you can say that the slope for this one is undefined. You can say the x-intercept instead of the y-intercept because it doesn't always have a y-intercept for a vertical line, but just knowing that it's a vertical line. Go over and find the x value of negative 1. Put that dot on your graph paper, okay, and then make your line. So that's basically slope. We're going to explore it a little bit more tomorrow. We're going to kind of expand upon it just a little bit in the 2-3b section, kind of talking about parallel and perpendicular a little bit. Do we have any questions about that? Do we have any questions about that? Are we good with that? Okay. Now, on the next page, you want to use graph paper, but I need you to add a little bit of note to. I want the slope. Tell me the slope. And the y-intercept. If it doesn't have a y-intercept, then tell me the x-intercept, okay? There are 12 of them. Let me give you some graph paper, and then that's what we're doing today, okay?